Hello, everybody. Welcome back. Um, I guess I took a very long nap, and my voice is now almost fully recovered. And you know, oh, so good. Oh, diet soda, diet soda pop. Oh, so good. Yeah. Um. Oh, this is good. Diet soda pop. Oh, yeah. I took a very long nap, and now it's like. By the way, Happy New Year. I took a very long nap, and it's like 8:30 in the evening of the New Year's Day. You know, some holidays like you take a long nap and like, oh my goodness, I don't want to sleep anymore. But when we wake up in the morning to go to work, it's like, oh my goodness, I want to sleep some more. So it's kind of ideal, right? On a holiday, you don't want to sleep anymore because you slept too much. But on a work day morning, you want to sleep some more while you can't. On a holiday, you can sleep all you want, but you don't want to sleep more than what you have. Didiolon, right? Plus, minus, minus, plus. Yeah. Yeah, I'm just enjoying that linear algebra, humanology over there. It's so pretty, such a pretty picture. I mean, yeah, yeah, it's very touristic, right? But it just look cool, exotic. I really like it. Yeah. I gotta wash this bottle because it's kind of sticky on the surface. Okay. It's soda pop bottle. Yeah, I would print that thing on the T-shirt. That's what I would do if I had money to do so. Anyway, yeah. So the I guess I guess I can look at this differential geometry book. Oh boy. Yeah, I'm looking at the book, about differential geometry. Okay. He talks about curvature a lot. Well, I guess I just study this when I have time. Mm-mm. I'm looking at this Gaussian curvature. Mm. Um, I'm looking at this geometry, different geometry. Okay, hopefully you don't get to see my whole spot while I'm reading this book. Oh boy. Yeah. Archimedean. Okay. Oh, it's good. Okay, so you have tangent vector and which is like subtraction of two position vector. Okay, that's like tangent vector, and then you have subtraction of two tangent vector. That's kind of like curvature, which is like velocity and acceleration concept. Okay, so basically second derivative of curvature is like second derivative of position vector, something like that. Okay, okay, that's what it is. Okay, well, whatever. So I think our next step in mathematical humanology is perhaps introduce some calculus like derivative or integration, right? Because we're kind of surprised that this linear algebra matrix concept have some application and some shadow thereof application in humanology. It was very pleasant surprise. It's like God's gift, kind of aha moment. So why don't we do some calculus? Okay, let's do some calculus and see if calculus has some application in humanology. Probably it does, right? Yeah, we're just making things up, right? So I'm sure we can make whatever analogy there is. We are very good at that. Concoction. Okay, so alright. Okay. It's such a pretty picture, so but I'm gonna erase this, okay, because we need space. Yeah, we said anti-gayism is like 99% good, 1% evil. Okay, then what's the corollary of that? Pro-gayism is 99% evil and 1% good, right? We have, but remember, pro-gayism is advocacy of gayism. Okay, so yeah, I guess some being showing some sympathy and compassion toward gayists. Yeah, it's a good thing, right? It's humane. It's love, right? Yeah, gayism is you. If you are a gayist, you're actually practicing gayism. Yeah, you have sex with the same sex. Okay, same sex. It sounds like six and that's pretty much what it is, right? Yeah, antichrist. Okay, Marco the devil. Okay, tattooism, gayism. Yeah, it's all that, right? Okay, so gayism, pro-gayism is you can be straight and pro-gayist. You're just like more sympathetic to gayists than you're pro-gayist. So yeah, I guess pro-gayism 1% good, 99% evil. Yeah, you can see it that way. Okay. But gayism itself is 100% evil. All right, it's destructive. So okay. Now, okay, calculus. What is calculus? Is this? Well, first of all, let's start with something what we are all familiar with. Okay. A car. Okay. Well, let's draw this. Do we need to draw XY coordinate? Sure. just easier, okay, to think in terms of xy coordinate, right? Xy coordinate, and you used to be here, all right, and you travel, okay, like this. You're driving in a car, okay, you know, you're driving in a car and your road is curved, so you are traveling, okay, a long time. So your position vector is at time one, your position vector, time one, in next second, you are here. Position vector at time two, okay? And this T1 and T2, they're called parameter. Well, position vector in general is a function of T, and T we call it parameter. Why? Because we're in the XY plane, so you have variable, right? X variable, Y variable. So typically we a function that looks like, you know, like y is equal to 2x plus 1, or you have some kind of circle here, right? So where the circle x squared plus y squared is equal to something like what? 2 squared or 4. But here circle moved. Let's say this is part of circle, okay? It moved a lot, so center point of the circle is around here, so it's like 5, 5, right? X minus 5, y minus 5. Okay, the radius is 2, so it's part of the circle, okay? You're going round the circle, okay? Traveling counterclockwise. Why x minus 5? Well, is a trick in algebraic geometry. Just to, because x is now bigger and y is bigger, right? So in order to preserve the equation, we have to subtract it. Okay, we talked about this before. It's like yin and yang, right? X becomes bigger, y becomes bigger. That's why, to preserve the equality of this equation, it used to be, if the circle is centered at the origin, it used to be x squared plus y squared is equal to 4, 2 squared, okay, because radius of the circle is 2, okay? But we are shifting to a positive x direction and positive y direction. So now x is bigger number and y is bigger number. So in order to preserve the equality, we are subtracting, okay, by that amount. We talked about this before, like balancing, right? X get bigger, okay, then we'll subtract it. Y get bigger, we'll subtract it, okay? Yin and yang, kind of minor plusism, didualism, whatever, right? So, okay. So P, Y is T time, called parameter, because it's neither X nor Y. This variable T does not appear in this XY axis, this coordinate system, okay? That's what we mean by parameter, okay? This is a parametric function. So in geometry terminology, algebraic geometry terminology, we have. Give me 1 second. Let me turn on the heater. Excuse me. So algebraic geometry. What is algebraic geometry? Is algebraic because we have equation like this, and it's also geometric because we have some pictures of this, like nice pictures of parabola or circle or vector. That's why algebraic geometry. Okay, so or we can say, I guess, algebraic geometry or geometry algebra, vice versa. So what is in algebraic geometry we have variables. Well, but yeah, we have variable like x and y. We have constant like 2 and 1. Okay, they're constant. And now we are introducing something new, which is kind of halfway between variable and constant. It's called parameter. Okay, parameter is a variable, but it's not neither x nor y. Okay, this is some third brand new variable. Is it z? No. Okay, this typically parameter is quite random. All right, sometimes time. All right, I mean you can think of this as time axis, the fourth axis. Yeah, you can see it that way, but parameter is more generic concept. Okay, time is just one example of a parameter. Parameter is a variable that does not appear in the axis, any of the axis. Okay, that's what parameter is. It's a variable that does not appear in the axis. All right. So parameter, there's another very popular parameter is length of this line itself. Okay, length of the line itself. Okay, it's kind of like spatial concept. Okay, and so that comes up a lot in like differential geometry or tensor analysis, or because it's kind of a relativity kind of concept, right? You're defining this something like the unit vector or coordinate in terms of itself, the line itself. Okay, the trajectory of your traveling. It's very, very relativistic kind of thing, right? Instead of having this absolute, upright, this coordinate that is fixed and absolute, now your coordinate is moving along. You are your own coordinate, that kind of concept, okay? Very relativistic, as opposed to absolutistic, okay? So, I continue to, I think I should, at least, continue to study like tensor calculus or differential geometry. I think I better study that. I think I should study it. Okay, I'm not saying I'm going to, but yeah, maybe once in a while I will. I guess if I get too bored. By the way, but before I do that, before we do that, I don't want to use I rather use pronoun you, we. Okay. By the way, so this, let's go back to the basic. Okay, so we have position. All right. Because we have to introduce this concept of velocity. Okay, velocity. I mean, something you're very familiar with, right? So that's the velocity, acceleration. Okay, that's basis of motivation of calculus, like differentiation. Okay, you know the Newton, Isaac Newton in Britain, and also Leibniz in Germany, which is a great, very famous mathematician. They invented calculus around the same time. There's a huge vitriol fight over who invented first. People say, oh, they are invented independently around the same time. Nobody imitated from another person. But that's what they say. Well, we don't know. We don't care either. Like, why does it matter, right? Who invented it first? So yeah, and also, as you can see, calculus is very convenient tool, but it's easy. Okay, it's nothing hard because when we talk about this, when we talk about the polynomials, the differentiation of polynomial, the formula it comes from this binomial expansion. Okay, we have like binomial coefficient, right? Yeah, like Pascal's triangle. That's origin of the calculus formula for, yeah, binomial for expansion of this x plus y to the nth. Let's jump ahead a little bit. Okay, so for example, as a side, okay, what is x plus n? What is x a? Well, sure, no, x plus y to the nth. What is this? X to the nth plus n x n minus 1 y plus blah 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 blah. Okay. Okay. And as you can see, instead of y we put h. Okay, x plus h to the nth. Okay, because later on we will have this formula. Okay, formula of differentiation. What is it? Limit when h is going to 0, x plus h n minus x n over h. Okay, so this becomes xn, they get cancelled, right? And you have h and h, so they cancel. So n x to the n minus 1, that's how it becomes, right? Because as you expand this binomial formula, there will be h to the zeros, h, then h to the square, h squared, h cubed, h to the fourth. So h cancels out here, but and xn it cancels out, but there be remnant h's. Okay, so that's why they all become 0, and so that's how you derive this nice differentiation formula. Okay, anyways, so we don't know yet. I actually yeah, we are kind of jumping ahead because to derive this position vector, velocity vector, then acceleration, it's kind of boring. Okay, it's kind of boring. So we're jumping ahead a little bit because I mean we are not in mathematics class, right? We are just having fun. We're just enjoying ourselves. Okay, holiday. So I guess humanological application of position vector, velocity, acceleration. Well, it'd be too easy, right? Like maybe the speed of your career progression, your speed of learning, something. Okay. And what is acceleration? Okay. So, yeah, mathematics and physics they kind of co-evolved, right? So, like Isaac Newton, for example, he was a great very famous physicist and also mathematician, right? So, yeah, speed, acceleration, they were physics concept, right? That's where this whole invention of calculus is from, like differentiation, right? Reverse of this differentiation is like integration. So they are more or less the same thing, right? Just different direction. So that's calculus, and uh, so uh, so there's this formula called F equal ma, right? Newton's formula, F equal ma. So we are talking about rotation, okay? We're talking about rotation. So you have this centripetal force, which is so force and acceleration. They have the same dimension. Okay, they're both vector, and they only differ in this constant. Same direction, only in the magnitude. There's only one difference. Constant m mass. Okay, so for unit mass, when m is equal to 1, yeah, force is equal to centripetal force of this circular motion. Yeah, it's centripetal force is same as acceleration. Okay, for the unit mass. All right. Just pretend this is a circle. Okay, you're driving. There's the circular park, or maybe this roundabout. You know, does your town have roundabout? My town does. You know, it's circular, right? So you can driving round and round and round and roundabout. Oh, or a park, whatever. Okay. I remember visiting Denver, Colorado. My goodness, such a beautiful town and wonderful people. On a vacation trip, okay? I mean, yeah, I went there because there was some kind of conference and there were some people from other cities. It was, to me, it was like 1 week vacation, maybe about a year ago. Yeah, just like in any other vacation, yeah, something horrible happens. Every time when I go to some vacation, something horrendous happened. Okay, what happened in that vacation when I was in Denver, Colorado? Okay, so people are from like different cities in that conference, and there was this one female. She's brown, okay, brown female. So neither black nor white, but some brown female. Okay, I some of those brown females, she could be Asian, she could be Indian, she could be Middle Eastern, or she could be Native American. Yeah, some of them have real beef with me. They somehow they really have this intense hatred toward me. Brown females. I can see some different ways. Okay, so they're brown females, and they're not attractive people. Okay, I don't get me wrong. I'm not generalizing. I'm talking about these brown ethnic females who are not attractive. Okay, that's the kind of people I'm talking about. Okay, there are brown ethnic females. What do I mean by brown? Neither black nor white. Brown race. Okay. Even in rice, not rice but rice, we have white rice, brown rice, and black rice, right? I love black rice. They are yummy. Oh, very nutritious. Anyways, I love brown rice too. White rice, yeah, I mean it's yummy, but not very nutritious, right? Just like white bread, you have white bread and you have brown bread, like wheat bread. I prefer eating brown bread because it's more nutritious. Okay. Anyways, so yeah, I have met some brown race females who harbors this intense hatred towards me, and I met one of them in that conference like 2 years ago. It was like hellish because she would just be so mean and rude to me. Like, oh my goodness. And because during the vacation in Denver, Colorado, I had it's a conference. Okay, so it's a several days, about 4 days long, I guess. So yeah, I had to see that crazy bitch. You know? Oh boy. And I'm not gonna fight with her because I can't do that. I mean, it's a conference, okay? It's like a class, you know. So I'm not gonna tell you what class it was. Yeah, it's about something more rather technical, okay? And people there are very educated people, right? And this crazy bitch, like ethnic bitch, like a brown bitch, she would be like real mean and rude to me, right? I'm like, my goodness, where is all this hatred coming from? And then because I have suffered several of those kinds. Okay, ethnic brown woman being very mean to me. She's neither black nor white, brown. She could be Arabic, she could be Indian, she could be Native American, she could be Asian or whatever. Okay, it's brown. Not by brown I mean neither black nor white. Okay, and many of these people have this third world mentality. Okay, so either they are first generation immigrants or second generation immigrants who are ethnic. Okay, yeah, they are American citizens, but they still their mentality is still from back in that developing world, third world country mentality. Okay, so they will be very nice to black people or white people, but in terms of me, an Asian man, they have this intense disdain, despise. Oh my goodness, you have no idea what I'm talking about. They're bitchy, like real bitchy. Okay, so why? I have several theories because I'm regarded as I have this reputation of. I'm sorry if I'm offending you, but in humanology we don't really care about hurting other people's feelings too much. Okay, we want to be nice, but you have to tell the truth, right? Whether it's offensive or not. So okay, all right. So I'm gonna just talk straight. Okay, I'm not gonna mince words or anything. So okay, again, we're gonna have some fun. Okay, we have plenty of time, right? We have like more than 2 hours left, so we'll get back to this later. But I mean, don't you like it when you are in school, your teacher or your professor talks about something else other than the main subject of the class? Yeah, it's like that. So yeah, one theory of why those ethnic women so mean to me. Oh my goodness. Yeah, we're gonna take a break, okay? That's my question to you. Why do those some of those race, brown rice females, why do they hate me, despise me, or treat me with such a huge disdain and despise and why? Okay, so that's my question to you. Hint: I'm an ethnic man, brown rice, brown race man, and some of those brown race females, they hate me. Sometimes they disdain, despise, treat me like shit. Okay, so why? What's your theory? Okay, that's my question to you. We're gonna take a break. Okay. It's a very funny story. Okay, so okay, we are back. We are back, and let's continue with this funny story. Okay, I mean at the time it was kind of painful experience because I nobody want to be made fun of, like such a crude way. It's not a fun experience, but it's a discipline. That's how I see it. Okay, you tolerate, you turn the right cheek, left cheek. Yeah, you be peaceful. I mean, because it's the conference. I cannot like fight with her, right? Then because I was there to learn something, and it's like kind of like class. And I mean, if I start fighting with her, no, there are other people there, right? So she was in. So they divide us as with several groups of like five people, right? And she was in my group, unfortunately, and it's God put her there to discipline me. Okay, so that's how it is, how it was. And so why do some of those brown race females hate me or despise me, or why? I didn't hate them. I can see some couple of reasons. First of all, um, yeah, I'm gonna say something that may be offensive to you, okay? But truth is not always pretty, okay? The reality, truth, is not always pretty, okay? But we talk about it. Why? Because we are strong people. We can handle the truth. Just like in that movie, like Jack Nicholson to what the Tom Cruise, A Few Good Men, right? Oh, Jack Nicholson, you cannot handle the truth. You're a punk ass. Oh, you went to Harvard Law School, whatnot, blah blah blah. But I'm more in general. You don't know what life is. You think you're smart, blah blah blah, right? So, so yeah. So I'm going to tell you some stuff that may be offensive to you. Okay, so what is that thing that may be offensive to you? Well, in general, I'm regarded as somebody very attractive. Okay, so try to dress up very nicely. Okay, I make conscious effort to do so. I exercise, I diet. Okay, and also I'm very sociable, nice to people. I tend to be very. I have very good reputation. All right, people in general love me very much. Okay, I tend to be quite popular person. Okay, uh, it can sound arrogant and kind of offensive to you, right? But that's just how it is. Okay, I tend to be regarded as somebody very charming, attractive, and I try to be attractive. Because I put a lot of time and effort to it. Okay, my hairstyle. I mean, not during the weekends or holidays that I don't even wash. I mean, I wash my face and brush my teeth, but I don't take a bath during the when I'm at home during the holiday or weekend. But on the weekdays, yeah, I take a bath in the morning and do my hair, dress up nicely, and whatever. So some of those ethnics, both male and female, brown ethnics, okay, immigrants or some close, near, relatively new descendants of immigrants, like maybe second generation immigrants, they still have this third world mentality, okay? Very developing kind of world mentality. Well, they are not quite civilized, okay? I've seen this many times because I have many ethnic friends and I deal with many ethnics because I myself am ethnic. Okay, I'm brown, right? Asian, 100%. Okay, yeah. So, um, yeah, some of those ethnic people, both men and women, have this third world country mentality. Okay, not very civilized. Okay, I've seen it before. Okay, immigrants, like fourth generation immigrants or second generation, like children of fourth generation immigrants. Yeah, some of them have this third world country mentality, very uncivilized. Okay, and she was one of that. Okay, so I recognized what it was. Okay, so I guess and she was not the only one of that kind. Like third world developing country mentality. I've seen those kind of women before, so that's why I how I recognized and I was oh not again. Okay, so yeah, I just turned the other cheek and just tolerate her being rude. That's fine. Okay, yeah, this conference is like 4 days long and yeah, I will probably never see her again in my life. So yeah, God want me to suffer and discipline me like this. Okay, I'll take it. All right, so I'm not gonna fight with this girl. Come on. So yeah, unattractive, very unattractive kind of woman. Okay, yeah, some ethnic brown race ethnic women are very beautiful. I've seen them. I know. Okay, so I'm not generalizing, but this woman and some other ethnic women who are rude to me, yeah, they are very they're quite unattractive type. Okay, so I understand, and why? It's like this. There's ethnic woman. I'm an ethnic man. We are both brown race. She's unattractive, and I'm very attractive. At least people regard me as kindly and generously regard me as somebody very attractive. Okay, so she knows that. So it's matter of jealousy. Okay, so we are both ethnic, and she's unattractive. I'm attractive, so I'm in a way superior, better than she is. So that's why she hates me so much. Okay, I have seen this happening before to me. That's why I recognize it quite fast. What type of jealousy and what type of hatred this is? Yeah, it's jealousy. Okay, so that's yeah. Let's get back to this. Okay, it's because that was outside. All right. Okay. Anyway, so position vector. Okay. Yeah, this is about 1,3, and this is what 3,3, something like that. Okay. Position vector. P1, P2. Okay. It goes around. Okay. So position vector. Now, this position vector, subtraction of position vector is called displacement vector. Okay. P P is the function of time. Okay. Because you at 1 second you are here, next second you are here, third second you are here, fourth second you are here. Okay. For every time your position is determined. Okay. That's why we call position is just a function of time. We don't care about some equation alone that is, it could be something like t squared plus 2t whatever, right? We don't care about that. It could be some yeah, it could be there could be some equation of time, but we don't care about that. Okay. Well, yeah, as a side, just for fun. Okay. Let's say this circle is centered at the origin, all right, and then let's say this time we correspond it with angle of this position vector. Let's say position vector is goes around this on the circumference of this circle, and time we correspond with angle. Okay. This was called the radian system. Okay, what is a radian? It's an angle expressed with a number. Okay, it's an arc of a circle with radius 1. Okay, it's unit circle, the arc length we call it radian. Okay, and because it's directly proportional to the angle. Okay, so now in radian system of angle, radian is a number. It's a real number. Like we have right angle as pi over 2, 180 degree as pi. Okay, what is pi? Circumference of a unit circle. What is unit circle? Circle with radius 1. Okay, so you are going around the circle, so we can correspond this angle with t, time, right? Time 1 second you are here. Time 2, when 2 seconds you are here, blah blah blah. Okay, so here then you have parameter t, so you have x-axis, y-axis, right? Let's say this is a unit circle. Okay, circle with radius 1. Okay, it's easy, right? X is equal to what? Cosine t. Y is equal to sine t. Okay, parameter. All right. What's the equation of this circle? Yeah, well, x squared plus y squared equal to 1. Okay? As a side, okay? So we don't quite need that, okay? So yeah, this displacement vector, let's say D, is equal to P2 minus P1. Okay, the vector subtraction, okay? Vector subtraction is like this, okay? Whereas the terminal vector minus origin vector, okay? So in time 1, you're here, that's P1, position vector. This is P1. In the next second, you are here, P2, position vector. You subtract, then you got displacement vector. Okay? And it's also delta P, okay? Delta P. Subtraction of two vectors is also vector, okay? So, okay. And what is T2? Can you read all this? Am I writing too small? Can you read all this? My goodness. You kind of can, huh? You know, let me bring back this whiteboard a little bit closer so that you can see it better. Whenever we do mathematics, I have to bring this board closer because we have a lot to write. And it's important that you know what I'm doing. Otherwise, what's the point of all this? This tripod walking. Okay. Such a ghetto that we are doing here. Shoestring budget movie. Performance, theatrical. Theater of the poor. Yeah, displacement, okay, that's why we wrote it D. But this delta, the Greek letter, it means difference, okay, difference. Okay, so yeah, it happened to be same D, kinda. Okay, so what is T? Okay, so T2, T1, right? T2 minus T1, we call it delta T. Delta means difference, okay? So and T is a scalar. T is not a vector, right? It's just a number, okay? Why? What is vector? Well, it's in here. It's a pair of number like A comma B, okay? Ordered set of scalars, okay? So yeah, it's two-dimensional vector, okay? What is one as a side? What is a one-dimensional vector? It's a scalar, okay? Because you only have one axis. Scalar, you have only x-axis, right? You have 0, minus, plus 1, minus 1, right? Blah, 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 blah. Yeah. You can define scalar as position vector in one dimension space, okay? You have minus 2, right? Right here, this vector, position vector, okay? This position vector for minus 2. What's the coordinate? Minus 2. Okay? It's a one-dimensional vector. Okay? Scalar is one-dimensional vector. And two-dimensional vector, we have like 2, 2, or 1, 2, 1, 3. Okay? Yeah, so yeah, okay. So one dimensional vector we just call it scalar, okay. Anyway, yeah, and in mathematics we say we distinguish scalar and vector, okay. So we don't regard scalar as vector, but technically it is a vector, one dimensional vector. But just matter of convenience, just to distinguish, okay. We say yeah, number is another vector is scalar. It's just matter of saying, okay. Yeah, just bear it with me. All right, so delta t, yeah, t is a scalar, okay, so delta t is also scalar. We call it h, okay, in differentiation convention, we just call it h. I don't know why. I don't know what h stands for. Maybe hypotenuse, I don't know why they particularly picked h. I don't know, okay. Now, we are slicing time by time, okay, that's what differentiation is, okay. Here t1 and t2, the difference between the two is like 1 second, right? What about like 0.0001 second, okay? Then the difference will be right now. So we are using our imagination. Let's say we have a time machine. Let's say just like in some of the Twilight Zone movie or some sci-fi movie, and Twilight Zone TV series or sci-fi movie or novel. Let's say we have time stopwatch that can stop the time, or even time machine we can go back in time, or we have this dial where we can control the speed of time, okay, like sci-fi science fiction imagination, okay, we are slowing down the time or going back in time, okay. Use our imagination, all right. That's something you need when you try to understand calculus, okay. We are slowing down the time, okay. Okay, and we are going back in time too. You're in time 1, you're in time 2. How about 0.5 time, 0.5 second? You went from time 1 to 0.5 second. That's your difference, your displacement vector, okay. And now how about 0.1 second? Ooh, yeah, 0.1 second, and blah 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 blah. You get displacement vector itself becomes 0 as time shrinks back to t1, okay. So displacement vector itself becomes 0. So limit, that's that's the concept of limit, where this h, which is delta t, okay, limit where as h goes to 0, delta t goes to 0, displacement vector becomes 0 vector, okay. Okay, yeah, we know that. Okay. Whew. No. So let's say we think about when this h delta t time difference is very small, okay. Typically you write this as a d p, okay, when h is very small. It's called differential, all right. dp. You know, in Leibniz notation, what is differentiation of y? You call it dy dx, right? What does this mean? It's very small difference, or like y2 minus y1, but very small time. Okay, it's differential. It has like limit concept. When time difference goes to zero, yeah, so that's the differentiation. Okay. Anyway, so that's dp. So what is velocity at this point? It's dp over dt. Okay. All right. Because average, so that's the velocity at particular time. Okay. uh, I'm not being the best teacher of calculus. I'm just kind of assuming that you all know all this, because what I'm doing here is giving you some different angle. Okay, so if you have never learned calculus before, uh, please catch up. You know, just do some Google search, whatnot, YouTube video about calculus, you know, introduction to calculus. Okay, they will teach you a lot better than I can. But if you already know calculus, maybe this is all boring, but I'm trying to give you some different way to look at it. Okay, different angle. All right, different take. Okay, as you can see, what is d, displacement vector? It's a delta p, right? And as we talked about, when h goes to zero, like time difference goes to zero, this guy becomes zero because it's displacement vector. Okay, but if you divide this very small number, like 0.001, by another small number, dt, which is like 0.0001, so you divide small number by very small number, it becomes something. It does not become zero. Okay, for example, you have 0.01 divided by 0.0001, which is even smaller number, is 100. Okay, very small number can be amplified by dividing by even smaller number. Okay, all right. So yeah, this number, small number divided by very another small number, it end up being something big, like 100. Okay, all right. So yeah, that's velocity. Okay. Uh, so yeah, velocity is always tangent. So you have this curve, right? What is tangent? You have this curve. A tangent line is a straight line that kind of touches on the surface of this curve. That's tangent line. Okay. Tangent line. Now, so that's velocity. Okay. This is trajectory that you are traveling along. Curve. You're traveling on the curve. Tangent line is line that touches on the surface. Okay, straight line that touches it. Okay. Okay. So yeah, velocity vector is just that. It's a displacement vector. Okay, divided by time. Okay. Okay. So in as a side, what time is it? 1 hour. Okay. As a side, I hope you can see this. It's kind of important. All right. So you again, we have this circle. Okay. Given time, the coordinate of this is cosine t, comma sine t. All right. And there's the position vector, okay? pt. So it's a vector function, okay? Input is time, which is scalar. Output, vector. This position vector. It's a vector function. Why? Because the output is a vector. Vector function input doesn't have to be scalar. It could be another vector, okay? A function is vector function if output is a vector, regardless what the input is. We only care what the result is, okay? If result is vector, then it's a vector function. If result is scalar, then it's a scalar function, whether the input is vector or not. Vector or scalar, doesn't matter, okay? So, okay. Yeah, so distinction between scalar and vector, it comes in handy, all right? So, when we talk about scalar, it means just a number, okay? When we talk about vector, it means at least two-dimensional vector, two-dimensional or above kind of vector, okay? So yeah, it comes in handy, the distinction, okay? So, yeah, so dy dx is the Leibniz notation of differentiation, and like y prime or y2 prime, yeah, it's kind of Newton convention of saying differentiation. So first differentiation is kind of like velocity, okay? Second differentiation, like d squared, dx squared, y, is more like acceleration, okay? As you can see. Just the prime symbol, yeah, well, Newton originally used this dot, y dot, then y2 dot. But when we type things, y prime is easier to write, okay? It's like y prime, kind of a tick or y single quote is easier to write in the typewriter, that's why. But yeah, it probably came from most certainly came from this Newton convention of writing first derivative just like velocity, second derivative is just like acceleration, okay? So that's the historical origin of this invention behind calculus. It came from this finding velocity and acceleration, okay? So it came from physics. But as you probably know or not know, differentiation, calculus, it has huge application in physics and engineering, mathematics. It's not just, it's no longer just about velocity and acceleration. That was the original motivation of inventing calculus. But calculus itself has huge application now. Okay, when was Isaac Newton alive? Was 1700s, something like that. So it's been like 300 years. Calculus is being used in contexts other than calculating velocity and acceleration. Okay, these kind of things happen all the time in mathematics. Okay, or in any discipline, in physics, biology. Okay, you invent something in this limited, very small context, small area of the entire mathematics or physics. Yeah, it's just about velocity and acceleration. But once you invent a tool, that tool, like for example calculus, is being used in other contexts, other area. or in mathematics or in physics. Okay. Yeah, it's like Jesus born in Nazareth. I mean Bethlehem, grew up in Nazareth, something like that. But he's now known like worldwide, right? Yeah, churches there everywhere. Okay, it's that concept. Okay, you start small, but a tree grow up very big, and just like Jesus said, whatever. Okay, so um, so let's say you are moving counterclockwise. Can you see this? Can you see this? Maybe it's time to erase all this. Huh? Probably a good idea. Oh, I'm getting hot. Let's erase all this. I mean, if you don't know too much mathematics, don't worry, okay? It's not that important. We're doing this for fun and also as an education. And how do I know this? How can I remember all this? Because I don't smoke marijuana, okay? That's why I remember all this. So don't smoke marijuana, okay? I learned this, what, 20 years ago, okay? At least. 25 years ago, but I still remember, okay? So yeah, don't smoke marijuana, alright? Okay? Okay, we're gonna take a break and then we continue this narrative in mathematics and physics. We're just spinning the yarn, you know, needing, making mathematical hat. We'll be back. Okay, we're back. So let's continue with this differentiation. So uh, it's like this. Okay. Uh, Now we are putting the circle at the center. Okay. You can barely see this because it's green. It's just axis, x-axis, y-axis, right? You have this circle. Just pretend this is perfect circle, okay? Oh my goodness, so horrible at drawing. And this angle also corresponds to time, okay? Let's say it's time 0, time 1, blah, 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 okay? So pi is 180 degree, okay? Radian system. So it's about like 3 here, okay? So 1, 2, 3. So degree, 1 radian degree as an angle is kind of about 60 degrees, okay? About. Okay? Slightly more than 60 degrees because you divide 3.14 pi by 3. Whatever, right? Is it? Yeah, so pi, let's think about this. 180 degrees is pi. It's like 3.14 blah blah blah. So 60 degree is equal 1 over pi divided by 3 is equal to 1.04 blah 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 blah. Okay, so and if you go to 1 radian 1, it becomes less than 60 degrees. Okay, so radian 1 is less than 60 degrees. Okay, radian 3 less than 180 degrees. Okay, all right. Anyway, so you have time 1 here. Okay, and then so you're moving around the circle in a roundabout. Okay, you're driving. So this is your position vector. Okay, your velocity looks like this. Okay, it's a tangent to this curve. Okay, because velocity cannot be curved; it has to be straight line. Okay, this is at this moment. Okay, let's say you are just walking around the globe. Okay, let's say there's this. Let's use our imagination. All right, there's this Earth. It's round, but locally look like flat. Right? It looks like it's a perfect like plane. Looks like that's approximation of this local curve. You have a huge circle. Okay, big circle. Locally, it looks almost like straight line, right? So that's the concept of velocity, okay? Okay, so approximation, all right? So straight line, okay? Velocity, okay? If you drive, let's say there's this land bridge around equatorial line, so that you can drive or walk all the way around the Earth. Okay, let's just use our imagination. All right. If you're driving down, it's as if you are driving on a straight line, but it's not. Globally, it's a circle, right? But locally, it looks like straight line, right? So that's the concept of this velocity. Okay, so in this particular example, P t is equal to what? Cosine t, comma sine t, right? Is equal to, algebraic expression. This is a vector notation because we have parenthesis and comma, right? It's a unit circle, okay? This radius is just 1, all right? -1. 1, minus 1, okay? For ease of calculation, okay? So, and then you have a unit vector I and j, right? Because in an xy plane, right? So I cosine t plus j sine t. Okay, it's a vector function, right? Now, if you differentiate, okay, we're using the product rule, okay? So ij, they're constant, okay? So di dt is 0, okay? We're using this product rule. I mean, is it product rule or addition rule, okay? All right, in calculus, okay, you have two functions, f times multiplied by g, okay, df. Oh. In this instance, Newton notation comes in handy, okay? F times g, f prime g plus f times g prime, okay? It's kind of a distribution rule of differentiation, all right? So, and I'm jumping ahead because we are not going to cover every single bit of calculus here because we are not doing mathematics. We are doing humanology, okay? So, if I'm covering something that you don't know, well, easy. Just go online, okay, or buy some calculus book and learn basics of calculus, okay? There are YouTube videos, Wikipedia, whatever, okay? Plenty of other websites, so calculus is fun, okay? It's fun, it's easy. Okay? So yeah, this is kind of, I forgot what it's called, maybe distribution rule of calculus, okay? And some constant c, if you differentiate, it becomes 0, right? And okay, so, and also, see how quickly we are running out of space? I'm just giving you summary, all right? Giving you the summary. Cosine t d cosine t dt, differentiating in terms of t is equal to minus sine t, okay? How to prove this? I don't know. I maybe they'll do some like Taylor expansion or something, just like binomial expansion. Probably that's what it is because well, let's actually see that. What is cosine a plus b? Well, maybe it's not as much as Taylor expansion, but maybe it's some trigonometric identity, I guess. Trigonometric identity. What is cosine a plus b? Let's look it up real quick. It can't be that difficult. Good. We have nice trigonometric identity here, okay? So let's prove why cosine t differentiated is minus sine t, okay? Because cosine a plus b is cosine a cosine b minus sine a sine b, okay? So that's why. Okay, let's do it. All right? Let's do it real quick.
we are proving this, and we don't have much space. Okay, it goes like this. Okay, so limit, what is f t df dt is equal to limit time goes to 0 f h, no, h goes to 0. Okay, because time, it can be, this is time 1 and then time 2, but you want to find your velocity at time 1. Okay, so time is not going to 0, it's h, the delta t difference in time, that's what's going to 0. Okay, so f t plus h minus f t divided by h. So that's the classical definition of differentiation. All right, what is this? Displacement. Okay, what is h? Difference in time. Displacement over time, difference in time, like delta position vector, difference of two position vector, that's the displacement vector. Okay, over time difference, that's velocity. Okay, definition of velocity. Okay, so is equal to, I'm gonna write in black so that you can see what is ft, what is our function? Cosine. Okay, you have limit cosine t plus h minus cosine t over, with h go to 0 over h is equal to, well, you're just expanding this. What is this? Limit cosine t cosine h minus sine t sine h. We are using trigonometric identity. Okay, cosine a plus b is equal to cosine a times cosine b minus sine a times sine b. Okay, it's just trigonometric identity. Okay, minus cosine t when h is going to 0 over h. Okay, again, we are running out of space, so we are going to erase this guy. We are ghetto. Okay, we are very shoestring budget, poor people. So h is going to 0. Okay, so when h is going to 0, cosine h becomes 1. Okay, so this is like becomes cosine t. Cosine t times cosine h, and cosine 0 is 1. Okay, so this guy becomes cosine t, and we have minus cosine t here, so they cancel out each other, and as h goes to 0, sine h, it goes to 0. Okay, so you have a situation where 0 over 0, I mean, okay, because sine h becomes like 0, right? So 0 over 0, that's where things get very tricky. Okay, so but there is an identity that known in mathematics where limit x goes to 0, sine x over x, this becomes 1. Okay, okay, so there is this identity, so we're going to use that. So that's why, so sine t, well, here it's a constant. Okay, because in this limit expression, h is the variable. Okay, so constant comes out of this limit, so because minus sine t and sine h over h, where h goes to 0, is 1. So that's why this whole limit expression is minus sine t. Okay, so yeah, we just proved it. All right, so sine t, yeah, it was differentiation of that is same. Okay, and we are using the distribution rule in the differentiation. So okay, so that d p dt is equal to, differentiate this 0 because I is a constant. Okay, so plus cosine t, we disregard it. Then distribution rule, I times d cosine t dt. Okay, that's what, minus I cosine t, I mean sine t. Okay, plus, yeah, so j is constant. Okay, so if you constant, yeah, we just disregard constant. Okay, it's CF. Okay, it's shortcut of this distribution rule. All right, so yeah, we differentiate sine t, it becomes cosine t. Okay, which is minus sine t comma cosine t, which makes intuitive sense. Why? Because right now we are in a positive first quadrant where everything is positive. So both sine t, cosine t, they are positive number, right? It's this coordinate position vector of this point here. So yeah, we are in happy land when everything is positive, right? But minus sine t in this first quadrant is a negative number, and guess what? That's correct, right? Because we have this velocity vector, because we are counterclockwise traveling. This vector, velocity vector, is a summation of this negative x vector and positive y vector. So cosine t is positive, so negative and then positive. So yeah, this makes intuitive sense, right? Now, so that's velocity. Okay, we have 1 hour and 20 minutes. Okay, our next step is acceleration. It's a second derivative, and which is very easy. Okay, very easy. Don't get scared. Easy stuff. All right, and it's fun stuff. Okay, I'm trying to invite you to this world of mathematics and physics. Okay, because it's good for you. All right, and if you don't understand everything I say, it's normal. Why? Because I'm skipping a lot. Because this is not a mathematics lecture series. It's a humanology series. Because later on we're gonna make some application to humanology, some analogy, at least in a conceptual level. Okay, maybe today maybe we don't have time to come up with exact humanological equation, but we can discuss hopefully on a conceptual level. Okay, so we're gonna take a break and then we'll continue with the acceleration. All right, second derivative. All right, okay. All right, we'll be back. Oh. And I'm gonna drink some. Okay. I did not touch any alcohol this episode yet, so now it's a good time to drink a little. Okay, which one do I drink? Over there, here. Okay. Here. That one. Okay, we'll take a break. Let's take 5. Okay, now that we are kind of deep into this episode, kind of in the middle, I'm gonna say something very offensive because it's a joke. Okay, don't get me wrong. Your sense of PG-13 or maybe PG-100, maybe some giga million. How about that? PG quadrillion. Okay, because this is something very offensive. It's a joke. Okay, your sense of humor is as dry as your grandmama's vagina. Okay. Ah, my goodness. Oh, your sense of humor is as dry as your grandmama's vagina or Mama Gina's vagina, whatever. It's just stupid joke. So offensive. So, I'm sorry I said it, but I just want to make some rhymes. Okay, that's all it is. I'm sorry. I mean, it's a joke, nothing else. Okay, just some rhyming joke and nothing else. It means nothing. I'm sorry. Oh boy, I'm sorry. It's just a joke, okay? So don't take it seriously. Oh, you insulted my grandmother? No, no. It means nothing, okay? It's nothing but a joke. So whatever. Now, okay. So we have velocity, okay? We will erase everything except this. This is velocity, okay? Velocity at time t. Minus sine t, comma cosine t, okay? Position at time t, cosine t, comma sine t. All right. So now, finally, we need to find. Let's just do it. At acceleration, position, vector. I mean velocity, acceleration. It's small v, okay? Kind of like large v, but yeah. Let's differentiate this. Minus cosine t, comma minus sine t. Okay. It should something that points over there, and it is correct. Why? Because it should be pointing toward the origin. Okay. So it's again F equal ma, right? I'm sorry. F equal ma. So and we have unit mass and unit circle. Everything is one. Okay, all constants for the ease of calculation. So now it's a unit mass. It's like 1 gram in this mg. Was it mgs? Meter, gram, second system, metric system. Okay, physics. It's like European, continental based. Because in British you have pound, you have mile, you have foot system, right? But in science you use continental convention, use meter, metric system. Okay. So mgs, meter, gram, second. In British scale, what is use foot? You use pound, libra, pound. Second, they use the same second, so FLS, whatever. You know, foot, inch, mile. Anyways, so you use that. Yeah, I mean, this British system of foot is kind of intuitive. What is 1 inch? About thumb length, I guess, right? What is 1 foot? About your one step for an adult. Yeah, it's very intuitive. It's a good system, I think. What is 1 pound? I have no idea. Maybe weight of your fist, your hand. I don't know. I have no idea. So, What is so yeah, differentiation, we just differentiate one more time from velocity, and then you got that. So yeah, F equal ma, right? M is 1, so acceleration is same magnitude and direction with force, as force. So it points toward the center of this origin, the center of the circle. So it's a centripetal force, okay, which is equal to centrifugal force. Let's say you have sling, you have string, and you have some stone, just like David versus Goliath. David used the sling, right? Slingshot. Woo! Okay. Oh boy. So you sling, right? You have string and stone. Stone attached at the end of string, and you do this. Or yo-yo, whatever, right? And it has centripetal force, and then centrifugal force is equal is the tension on the string, okay? And if the tension, the force that is imposed upon this string, let's say string is a person. Actually, it does happen. Don't you know, in the Olympics, Winter Olympics, a guy kind of rotates a woman as he does this skating, couple skating, right? Yeah. And as he rotates faster and faster, yeah, the arm of this lady, the female figure skater, it's gonna hurt. She's gonna feel this tension as he rotates her. Or in a circus, or maybe in some swing dancing. Yeah, actually it does happen, right? So she'll feel this centrifugal force on her arm or her shoulder, okay? So, and he's rotate faster and faster, it's gonna be just too painful, more and more painful, okay? So she'll feel that centrifugal force. Let's say you have this string, right? And let's say this string is alive. It feels the. You're using some imagination, okay? Yeah. In this way, physics can be very interesting. You use your writer's imagination, all right? Let's say this string is alive and it feels the force. As you rotate it faster and faster, string is like, oh, hey, it hurts. It's a string, it's no longer a person, okay? And you are the satanic, oh yeah, I'm like a what, sadist. So yeah, string, feel the pain. Yeah. This string is like screaming, and then I cannot take this anymore, and string dies. Okay, so the stone attached at the end of string, it breaks off because you're rotating too fast. So the string dies, it breaks in half, okay? And stone goes like, ah! Okay. Because string has maximum tension it can tolerate. String, a cord, maybe it's made with nylon, maybe, whatever, right? Because what is that strength come from? I mean, string, it has this covalent bond in a molecular level, atomic level, is covalent bonding. Okay, that's the strength of the string. And if centrifugal force exceeds the maximum tolerance of this string tension, then yeah, it will break. Okay, all right. So, easier example: a sourdough or your pizza dough. When you make a bread, yeah, it has some tension, and you start to rotate it. It be not that difficult to break it. Okay, you should rotate. Okay, so even not too hard to break that sourdough or dough. Okay. Anyway. Okay, so yeah, in the law of motion, Newton, yeah, it's an action reaction, right? So that's why centrifugal force that goes outward is equal to centripetal force, all right? action direction. Okay. Now, okay. So we have velocity here and then velocity here. For when we do differentiation, we go to like time difference is equal to 0, like momentary, right? So next velocity will be like, okay, velocity here is like this. Next, closer in time, it will be like this, okay? All right, small time difference, okay? So, and vector, we can always parallel transfer, all right? Vector, as long as we preserve the direction, this vector we move it to this direction. I mean, we're just moving the position of this origin, okay? It's pointing to the same direction and we preserve the length, then they are equal vector, the same vector, okay? So, we are making parallel transfer of this vector, okay? You have original vector here, and then next vector goes like this. Very small angle, right? Parallel transfer. And let's say this is a V1, this is V2. This difference is the delta V is equal to V2 minus V1. Okay? That's difference in velocity, change in velocity. It's a very small vector, acceleration, right? It's not acceleration yet because we have to divide by time. Then it becomes acceleration. But as you can see, it's a very small difference, very small vector, tiny little vector, delta V, okay? Difference in velocity. Why? Because it's a constant speed. What is speed? Speed V is a scalar, is a absolute value of velocity vector, okay? What is absolute value? Just length of this arrow. That's the speed, okay? Speed is constant. You're driving around this roundabout or around the circular square, city square or circular park. You're just driving around in a constant speed, okay? Your speedometer stays the same, what, like 20 miles per hour or 50 miles per hour. It's same speed, but we are changing the direction though. So there's the difference in velocity, the direction, okay? That's what this small vector represents, all right? It's small because you're only changing the direction, but not the speed, okay? We are quantifying the directional change, okay? Again, we are giving it, probably some of you is something very familiar, but I'm just giving it a different spin that your physics or mathematics teacher didn't tell you. Why? Because they have to cover many stuff, so they don't have time to have some philosophical discussion of what acceleration is, right? Now we are doing it, okay? It's something supplement or in advance, I mean, something supplement or something complementary kind of education, continuing education. We're giving it a different spin, okay, so to speak. Okay, different angle review, all right? It's not exactly advanced, but we are giving some philosophical twist to this physics and mathematics, okay? Because we are in the world of humanology, we do everything there, okay? We even do religion, all right? And also circle, yeah, let's do some religion, okay? We have 1 hour left in this episode. Circle is a very significant figure in Buddhism, all right? So that's that. So let's get back to physics, okay? More religious interpretation, maybe later, okay? So yeah, this small difference, yeah, it quantifies the directional change, all right? Okay. So guess what? Yeah, it's pointing toward this direction. Okay, direction toward the origin, right? So that's good. That's good. That's good. Because we do this parallel translocational vector to preserve what that vector is. That's right here. Okay, that's the origin, right? I mean, the location of this moving vehicle, and uh, guess what? As this two v1 and v2, they get closer and closer in time. You used to have a triangle like this, right? Let's say v2 is right here, right? It's a kind of horizontal. Then acceleration it looked like this, right? But as we go back in time with this time machine, this is v1, v2, okay? The angle, this angle becomes more and more close to right angle, okay? So that's why at this point, let's say this angle is theta, and we find the limit value, delta t goes to 0, theta eventually becomes what, 90-degree angle, okay? And it points directly to the center of this circle, okay? Because it's 90-degree with this velocity. All right, can you see all this? Am I writing it too small? Yeah, you can kind of see it, huh? I'm sorry. I'm sorry. How about this? Just for like, what, 5 seconds? I'll let you see this, okay? Here. Okay. I mean, I don't have much money. Alright? So we gotta make do with what we have. You got it? We'll take a picture or something. We gotta make do with what we have, okay? So, Charlie Chaplin movie, why is it so funny? Because his character is what? Charlie Chaplin, what was his character called? He's a poor guy, right? I forgot the English word. Charlie Chaplin, tramp, right? Tramp, whatever. Yeah, he's very poor man, so that's why it's so funny. He's so inventive, right? Yeah, necessity is the mother of invention. So he invented all this funny stuff because the character is so poor. Because Charlie Chaplin was a very poor man, all right? And I was listening and also to Billie Holiday's jazz music, and but Dee Dee Bridgewater, yeah, I think she's by far better singer. Of course, Dee Dee Bridgewater, she's quite contemporary. The jazz singer, what's her name again? Yeah, there's Etta James, Ella Fitzgerald, all these famous African American jazz female musicians, singers, and Billie Holiday. She is one of the pioneer of this jazz singing, female African American vocalist. I mean, yeah, she's cool, okay, but she's not one of my favorite, okay. Because she made a big step. She's a pioneer, right? But later, jazz female African American vocalists, yeah, I like later ones like Dee Dee Bridgewater or Etta James or they built on top of what Billie Holiday did. So Billie Holiday, she's cool, but later musicians they built on top of what she accomplished. So later musicians, I like later musicians better. Okay, like Ella Fitzgerald or okay. Anyways, my favorite Christmas carol singer. Some of my favorites. what's her name? Amy Grant. Yeah, she's fantastic. She's white. She's Caucasian female. Yeah, so Caucasian can sing. Okay, don't get me wrong. Anyway, but yeah, the Billie Holiday. I read her biography, and she used to work as a prostitute. Okay, one time. She was very poor. Okay, so yeah, if you used to be, or if you are a lap dancer or doing those less prestigious work, maybe you are a lap dancer or strip dancer in gentleman's club. It's kind of gentleman's club is kind of misnomer because that's one place where you cannot find any gentleman. Okay, gentleman's club. All men becomes like an animal. Okay, so it's not gentleman's club. It's animalistic men's club. Okay, so yeah, if you work in that industry, yeah, you can still make a big grade because I don't recommend women to go into that kind of industry, like adult film industry. Of course, yeah, I watch adult film because I'm a single guy, but we have already enough adult films, so I don't think we need to make any more. So I recommend women not go into those industry like prostitution or escort service or lap dancing or strip dancing or adult film industry. I recommend women not go there. Why? Because it's first of all it's you're sacrificing your social status, okay, your reputation. So I care about women. That's why I recommend women to get out of that industry and don't go there, okay? Because we don't need that, okay? And yeah, let me just put some chapsticks here. Oh, my lips are too dry. How about this? Your sense of humor is as dry as this aging Alaskan Asian man's lips. How about that? Just kidding. Oh boy. Yeah, so Billie Holiday, she used to work as a prostitute, but later on she became a fantastic singer. So yeah, even though you have some past that's not very prestigious, well, you can make changes, okay, and become very successful as some other more legitimate profession, more socially glorified profession. Okay, so yeah, don't let your past tie you down. Break free from your past and start a new life. Okay, all right. Because all those professions where there's this stigma, social stigma attached to it, and also it's not safe. Okay, you don't want to get become a victim of some violence because there are bad men out there, men infected by this violencism or criminalism. Okay, and also you don't want to get STD, sexually transmittable diseases. So yeah, that's why it's not recommended that you go into those industry. Okay, so okay. Uh, all right, so we find the acceleration. So okay, we have very small delta v here, and we divide by small time. So acceleration becomes a sizable number. Okay, because we are dividing small number by even smaller number like dt, differential of t, very small time gap. So yeah, it becomes sizable number acceleration. Okay, this acceleration. Okay, it always points toward center. Because F equal ma, so m is 1, so centrifugal force, centripetal force. Okay, all right. So that's the acceleration right there. let's erase everything, and so we did everything, okay, that we need. Now let's take a break and do some humanology stuff, okay? It's kind of religious too, more philosophical. Yeah, I mean, humanology, we use science, right? So we accused, okay, the metaphysical world, physical world, and physical tool, and we have science tool for, okay, this is a subject, right? Target, tool. How about goal? You have religion, science, okay? These are the tools. Metaphysical universe, physical universe. They are the goal, tool, goal, okay? It's a matrix, okay? It's 2 by 2 matrix, okay? It's a table, okay? Physical universe, metaphysical universe, physical universe, okay? These are the tools. Religion is tool for to understand metaphysical universe. Science is a tool for to understand physical universe. And the error in this direction, you're using scientific tool to understand metaphysical universe, is an error of psychology. Okay. Now, error in this direction, you are using religion as a tool to understand physics, physical universe. That's the middle age, you know, this flat world hypothesis, or oh, the sun revolve around the earth, or okay, so that's the error of Christianity in the Middle Age, Dark Age, okay, or this witch doctor, you know, voodoo doctor, all those, yeah, religious tool. So they are both erroneous. But so you have psychology, and then you have Christianity, Xmas, Christmas, okay, cross, okay, Christianity symbol. Okay, how about cross? Not a slanted cross, but real cross. Christianity, okay. Psychology, yeah, Greek letter psi, okay, psi. They're both erroneous, okay. Wrong application, like some creationism. I mean, some creationism makes sense, but some other creationism is erroneous, okay. So because they're applying wrong tools for the wrong topic diagonally, okay. It's supposed to be this: religion to understand metaphysical universe, and science to understand physical world, okay. But humanology, why is it work? Why does it work? Why is it gonna succeed? Where psychology failed, because we combine both, okay. We use both tools, religion and science, to understand metaphysical universe, also physical universe as well. We use both. We don't use just science, we use religion as well, okay. That's why we're going to succeed, and we have succeeded so far, okay. We keep on succeeding, okay, to explain metaphysical universe. Now we're going to take a break, and we'll make some application of this velocity and acceleration, okay. We make some application to humanology. While we take a break, why don't you think about that? How would you apply concept of position vector, velocity vector, and acceleration vector to humanology, human metaphysical universe? How would you apply that? Okay, I'll leave that to you for now, and when we come back from break, yeah, we'll talk about it together, okay. All right, let's take 5. All right. we are almost back. Give me 1 second here. Okay, let's talk about religion a little bit. Okay, yeah, Buddhism I'm not too familiar with. Okay, okay, so but Christianity, yeah, because I grew up as a Christian and I grew up in churches, and so yeah, so let's talk about Christianity a little bit. So it's this cycle. Okay, we have slavery, then Exodus, and Promised Land. It's cycle. We do it again and again and again. What is it? We once were slavery. We were slaves of ignorance. Okay, so that's the Egyptian slavery. Okay, slavery, Exodus, and then Promised Land. Okay, land of milk and honey. Okay, well, original sin. What is original sin in humanology? Ignorance. Then Exodus, education. We learned this science, mathematics, you know, velocity, acceleration, blah blah blah. Right. Now we are about to enter the promised land, humanology. Okay, land of milk and honey. So it's a very fertile ground. This mathematics and physics. Very fertile ground for humanology. Okay, so that's what we're doing. Now let's enter the promised land. Okay, land of milk and honey, humanology. Okay, make some application. Let's make some application to the human world by analogy at least. Okay, if you don't, we have 40 minutes left. We are not sure we're gonna come up with some brand new humanological equation or not. Okay, so yeah, circle is very significant symbol in Buddhism. Okay. Okay. Also in Taoism as well, to a certain extent. Chinese, I mean, Indian Buddhist symbol like swastika, known as swastika. Now it has some stigma of this Nazism, but yeah, it's a Buddhist symbol. It's like thousands of years old, perhaps. And in Taoism we have this. Chinese Taoism we have this, right? Yeah, they are very similar. It's circular, right? Okay. And in Greek, in the Western world, yeah, circle. And you have later on they add this x y y axis, right? Circle. In geometry and algebraic geometry, right? Yeah. With circle and straight line, right? In Greek tradition of geometry, mathematics, European mathematics, yeah, circle is very significant symbol. I mean, object. Okay. We're combining again philosophy and science. I mean, religion, science, West and East. We're combining all of them. Okay. It's a party. Okay, so metaphysical party. You don't have to call it orgy. No, it's just party. We're partying. Okay. Just like in the Michelangelo's or Leonardo da Vinci's painting, right? We have this Socrates and Plato and all these famous philosophers in heaven or in academia, whatever. Yeah, we are having that kind of party here. Yes, it's very ghetto version of that because it's just me and laptop computer in my house. Well, but at least I'm drinking, so at least I'm drinking vodka. Okay, this is a nice party. Okay, so okay, so what are some applications? How would you apply this velocity and acceleration? I mean, easiest way would be, yeah, progress in your life, in your career. Okay, constant speed. You have some sudden change of direction in your life. Maybe you get married, or maybe you have a child, brand new newborn child. Yeah, it changes the direction, so there's some acceleration there. What is acceleration? Change in velocity. Okay. Speed can change. You can accelerate or decelerate, or you can just have the same speed, but you change the direction. Then there is acceleration there. Okay. Yeah, you can see it that way, right? There will be the easiest application of this concept of velocity and acceleration in life. Maybe you change your profession, career goal, or maybe you get married, or you have a new baby, you get a new job. Yeah, change in direction, right? Acceleration. Okay. Yeah, there'll be easiest application, but we don't want to be satisfied with that. Okay. We want to do some more because that's just too obvious, too easy. We want to challenge ourselves. Okay, so we talked about ideologies because we talk about ideology a lot in humanology because that's kind of interesting. Okay, especially evil ideologies. That's our favorite, right? Because the snakes. We eat snakes. We are snake eaters. We are eagles. Okay. That's one particular eagle species that it feed on snakes. Okay. Because snake is what, two-dimensional animal, right? Eagle is three-dimensional animal because it can fly. Yeah. Oh, high protein. Oh, snakes, yummy. Uh, in Korea, probably in Japan and China too, we make vodka drinks out of snakes. How? We have this glass bottle, big bottle. We put a live snake there, like viper, poisonous snake, right? And then we pour down this drink, strong liquor. It's not vodka, but it's a Asian strong drink, liquor that can catch a fire. Okay, yeah, Asia have that too. It's not vodka. Vodka is like Russian, right? So yeah, you Asian drinks. Okay, you put down, and then snake kind of comes up because air is running out, right? And when just before we kept the strong liquor in this bottle with live snake in there, yeah, we kept it. So you have this, and this snake is kind of frozen, right? It dies of suffocation, but it's still long. It's trying to, oh, let me breathe. Okay, and then we put this as a display, as a decoration in a house. Okay, so you have this bottle, clear glassy bottle, and with a snake in there, long snake, right? And you have strong liquor in there, and we put it for several months or several years, and we drink that. I have drank that, but I have never eaten snake meat ever. I'd love to try though. Whatever. So yeah, we feed on snakes, okay? We feast on it as a humanologist because our food is those evil ideologies. We eat it. Okay. That's many times what we do here, okay? So yeah. They are our praise. Okay, we kill it and we eat it, okay? Something is in my eyes, so I'm gonna wash it off. Okay, so let's continue. So let's talk in terms of this ideologies. Okay, so let's say your life revolves around this ideology. Okay, so there's some ideology here. Let's say tattooism, gayism, whatever. Okay, or you don't have to think of about evil ideology. We human beings, we are one level lower than concept. What is concept? Ideologies, okay? Any concept is an ideology, okay? So let's say you're, for example, what's your job? Day job. What do you do for a living? I have no idea because nobody's here, okay? Okay, so let me ask myself, what is my job? Yeah, office worker, paper pusher, okay? That's what I do for a living. Okay. I like it because something new. Yeah, paper pushism. Okay, that's what I do for a living. My life kind of revolves around it. It binds me, okay? I'm solving the customers, whatever, right? Or how about cherry or apple? Okay, but we use apple too much, okay? Cherry, the cherry farmer. I love cherries. Oh my goodness, love cherries. Fantastic fruit. So you're a cherry farmer, okay? Cherryism, okay, because that's what you do for a living, okay? You love cherries, you grow cherries, and cherry make give you money, okay? So cherry is like your god, okay? You serve cherry, you take care of cherry, and it gives you money. You sell cherries, okay? Okay, so yeah, cherry give you happiness, money. It's like God, sun, okay? Just like the earth revolves around the sun by the gravity, okay? So gravity is that centripetal force in a planetary motion. You have sun, you have earth, and so earth revolve around the sun. It's bound. It's like a string, okay, sling. That force is you have sun, you have earth, you have moon, of course, but it's same rotation, right? Earth moves around the sun. Okay, so that's the force, centripetal force, which is probably you got this right. Gravitation, gravitational force. That's the centripetal force. It's the string tension. You know, this binding force. Okay, but displacement. So work is just energy. Okay, energy is equal to work in physics. It's a force dot product uh, displacement, which is a delta position vector. Okay, this is the definition of work. So force is that way, and this is displacement vector. Okay, so F vector times displacement vector. Okay, which is delta, the difference of a position vector. So displacement vector is like this way, right? Why? Because you have two position vector here, P1, P2. Displacement vector is like that way, right? P2 minus P1, right? This is D. So yeah, it's always tangential and orthogonal, like right angle to this force. That's why dot product is, what is dot product? Absolute value of F times absolute value of D displacement vector times cosine theta, and cosine 90-degree angle is always 0. Okay, so this, there's no work, there's no energy. That's why it's a perpetual motion. Okay, there's no input energy or output energy. It's just perpetual motion. It's inertia, law of motion. Okay, Newtonian motion. Yeah, inertia. It just go round and round forever without any extra energy input. Okay, it's like, okay, you push some object in the space when there is no gravity whatsoever. You push it and it goes constant speed forever. There's no acceleration there. Okay, here, yeah, there is acceleration, but the direction of this force, because direction of this force and this movement is right angle, yeah, there's no work, there's no energy lost or gained. Okay, so it's Just like pushing some object, it goes forever with constant speed due to inertia. You know, Newton's law of motion, inertia. Yeah, it's just like that. Okay, goes round and round forever. Okay. Why? It's because of this. Okay, this perfect balance. So before we, how much time? We have 30 minutes. Okay, time's running out. Before, because we have to understand this physical universe first. We have to understand it thoroughly. You know, even in a philosophical level, ontological level, we have to get to the bottom of this. Okay, we have to understand physical phenomenon thoroughly because there will be our model tool to understand metaphysical universe. Okay, so that's why it's worthwhile spending some time to build some foundation. Okay, strong foundation. Okay, so. Rocky foundation. All right. This is going to be our model to understand, tool to understand metaphysical universe, right? Which is invisible. This physical universe is very visible. You have sun, earth. Okay, you're using this writer's imagination. Say, oh, sun is this small. We are like God, giant, bigger than sun and solar system. So we're looking down, bird's eye view. Okay. We're pretending we are some giant, universal giant, so that we can take a look at sun and the earth. We do time traveling because they're moving very fast. Okay. We are controlling the speed of time, right? Yeah, imagination. Okay. Okay. Let me turn off the heater, it's getting too hot. All right. Okay. Okay, we talk about, we're going to erase this for now. Because we need to understand this physical universe first. Most of this is something I learned in high school, Korean middle school, and American university, okay? On Earth, okay? This planet Earth, and you have moon, of course. Earth, moon, right? And there's some satellites, okay? If you shoot a rocket, if you just shoot a rocket, maybe fail to get out of Earth, or, okay. Escape speed, okay, escape velocity, okay, because Earth rotates, right? It rotates by itself, and it has this self-rotation, Earth, around its axis, and it has this big rotation around the sun, okay? Let's say Earth rotates this way around the sun. I know, let's just assume Earth rotates by itself in the axis, okay? Just simplify, okay? We're not going to go into too much detail, alright? So, you throw out a stone, okay? Perpendicular. Straight up. Because Earth rotates. It's relative speed concept, okay? In terms of Earth, planet Earth, even if you shoot the rocket straight forward, like perpendicular angle, because Earth rotates, and in terms of Earth being static, your rocket goes like this. Oh, it failed to get out of the Earth's orbit. Okay. But if you put some more injection of this fuel, now you're more prepared. Then yeah, now I'm in the orbit, my satellite. But if you happen to inject more fuel. Oops, too much fuel. Now I'm out of the Earth orbit, so I'm spiraling up and up and on. I get out of Earth orbit. Okay. Maybe you want to go to Mars. Okay. Voyager mission, whatever, right? Okay. Why? Because Earth rotates. Okay. So that's why even if it goes perpendicular up, in terms of Earth being static, yeah, you are kind of making this spiral motion, right? Do you understand what I'm saying? Okay. If not, well, go back to basic and do some internet search, and then you can catch up. It's not that difficult concept. It's relative speed, okay? To make it easier, let's say you rotate like this, okay? It's as if you are standing still, but the whole world around you is rotating around you. Okay, let's say you go to amusement park, okay, and things around you are rotating. That's the same picture where that room, rotating room in the amusement park, is standing still, but you yourself is rotating because you're in a swivel chair. Okay, it's the same scene. You see things moving, the rotation, okay, and you get dizzy. That is the same concept, all right? Okay. Okay. So, we're gonna talk about ideology, and let's say there's some central ideology. Okay, ideology. It could be your profession, Appleism. You're an apple grower, so your life revolves around apples, apple farming. Okay. I love apples. Oh my goodness, I love apples. Because orange, I love oranges too, but I have to peel it. Oh, it's too much work. Apple, you can just wash it and eat it. No need to peel. But if I try to do that with orange, like, oh, it's so bitter. Oh, orange peel. I mean, I love orange chicken. Orange chicken, Chinese food, yeah, they use the orange peel, but they process it. They dry the orange peel, and yeah, it become very yummy. Okay, but you have to dry it, right? Yeah, I love orange chicken. Anyways, we have 20 minutes left, so yeah, let's get to it. Okay, so ideology, yeah, maybe your profession or any kind of concept. Maybe it's family. Okay, any ideology, your family or your job, yeah, you revolve around it, right? Your life, center of your life is this ideology. Okay, you do everything for your family. You work for your family. You go to work for your family to feed, to bring food on the table for your family, your wife and kids. Okay, your life revolves around as if this is sun and you are planet Earth. Your family gives you stability, gravitational pull. Okay, it gives you light, happiness. Your family, your wife and your children. It's like as if your family is your God, something higher than you. They're your boss. You work for them. You work so hard. You take all the bullshit at work from your customers, from your superiors, from your colleagues, even from your subordinates. They give you attitude. Well, you suck it up because you need this job in order to bring food on the table to feed your wife and children. Okay. Yeah, your wife and kids, your family, as if they are your boss. You work for them. Okay. And they are your boss. Also, they are happiness giver, like sun. They give you motivation to go to work, to wake up in the morning. they give you happiness. It's like they are God concept. Okay, family concept, ideology, familyism. Your life revolve around that concept, ideology, familyism. Okay, it gives you stability. Okay, you have a house, home, family. Okay. Now I'm getting cold. So I'm gonna. How about like some other any concept? Okay, let's say houseism. You work for your house to make it pretty because it's your hobby. It's a good hobby. Okay, you decorate your house, you fix it, you spend tremendous money and time to decorate your house to make it better. Okay, you do it yourself, right? Houseism. Okay, it's a concept. Okay, ideology. Houseism. Okay. Yeah, because it gives you happiness. Just that working for your house to make it better. Yeah, you love it. Okay, you spend time and money for it, pain and suffering for it, for your house. It's as if your house is your boss. Okay. Okay, so yeah, it gives you something to do. Okay, it makes your life stable and not boring. If you're doing nothing, you're kind of unstable, right? Oh, I'm bored. What do I do? But it gives you something to do, right? So it binds you, give you some stability, this gravitation. Okay. Why is it circle? Or because you do it again, again, and again, and again, and again. At the same center. Your hobby, same family. You work for them again, again, again. You're moving day by day around time, in time, along time axis. Yeah, just like a clock. Pick, pick, pick. Or yeah, clockwise. Pick, 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 pick. Just time needle, clock needle, okay? You go around and around and around and around. But at the center, it's the same family, your wife and kids. You work for them, okay? So yeah, that's the one interpretation of this. Do you like it? Yeah, come up with your own, okay, analogy. But so far it's been only conceptual level. We didn't quite come up with some humanological equation yet. Maybe some other time. We have only 15 minutes left. Okay, maybe some another time. Okay. I mean, calculus is interesting, but because I have done it for a very long time, calculus, like since high school. Oh my goodness! So I feel kind of jaded about it. It's to me, it's kind of stale subject, calculus, because I have studied for a very long time, calculus, calculus, calculus. So to me, it kind of feels stale. So to come up with some differential or not exactly differential equation. Differential equation, I don't know much about it. Okay. So this calculus, oh my goodness, not again. So it's kind of jaded subject for me. So to come up with some humanological equation that involves calculus, I don't quite feel like doing it. Maybe I will leave it up to you. Okay. Maybe you are new to calculus. Then yeah, by all means do it. Okay. Some humanological equation that involves some calculus. Okay. And so Gravitation, I mean, it's very important in physics and also Einsteinian theory of relativity, general relativity. Okay. Gravitation is significant in humanology in terms of entropy, entropic gravitation. Okay. It's kind of the temptation of the evil, temptation of Satan. Okay. Chaos, disorderliness. Yeah, that's evil, right? We call it entropic gravity. Okay. Gravitational pull that we have to fight against. We have to resist the temptation of evil. Or this temptation of evil ideologies so that you become gay, you smoke marijuana, tattoo piercing. Yeah, the temptation of the evil ideology. Let's say, okay, let's be cool. Let's make some beautiful analogy. You're planetary. You're living, let's cosmos, universe, okay? You like those stuff, right? Star Trek, Star Wars. Why is it so popular and appealing to people? Because cosmos, universe is beautiful. You watch all these pictures from Hubble telescope. Yeah, beautiful pictures, right? From NASA, you know. Beautiful pictures of the universe. It's something exotic. This universe outside planet Earth. That's why some people are willing to spend millions of dollars for space travel, right? Oh boy. Yeah, it's something exotic and beautiful. Universe, right? Planetary. Okay, let's do that. Okay, because we are here in humanology world. It's all about intellectual entertainment, isn't it? So yeah, let's have some fun. You're a traveler in the space, okay? And there's this evil planet. Planet evil, okay? You tattoo piercism planet. Okay. You are traveling on the spaceship. I don't know what spaceship look like. Maybe it look like a fish with fin and tail. Look like a fish, and you are here. Hey, I'm smiling. I'm happy because I'm space traveling. Looks like a fish, okay. Nice, streamlined, you know. Whatever, but I mean, in space, there's no air, so that's why satellites, it doesn't have to have this streamlined figure because it's in space, there's no air, okay. And once you get out of orbit, Earth orbit, but typically they have these layers, right? So that the surface of this ship doesn't burn in the space. I mean, when you get out of the Earth orbit, which is full of air. So you have outer layer and you kind of take it off once you get into space, and you have this kind of angular shape of satellites, whatever, Voyager, space, whatever. Yeah, it doesn't have to have that nice, streamlined, smooth curve because there is no air in the space. Okay. Anyway, yeah, you have fish in the space. This is a spaceship. It kind of look like fish. Okay, and there's this tattooism. Okay, this huge planet, evil planet, tattooism. And there's this gravitational force. It attracts this helpless, naive person. Okay, so no, oh, I try to resist, but oh, this evil temptation, this gravitational force of this evil ideology is just strong to resist. Peer pressure. Okay. The size of this ideology is as big as the summation of power of those people that subscribe to this evil ideology. Okay? Once you subscribe to it, oh, then it gets that bigger. As big as your power, your influence. If you're a big celebrity, and if you're a tattoo piercist, then yeah, it gets a lot bigger because that particular celebrity is very big influence. But just people like you and me, who is not celebrity, yeah, it adds up. Many people, nameless, not very famous people, but there are many. Okay, this adds up. So tattooism, the power, the gravitational force, the mass of tattooism as an ideology is the summation of power of all subscribers. You have big celebrity become tattooist, okay, celebrity, and many of us, nameless people, unknown, anonymous people, but there are many of us, and each of us subscribe to tattooism by getting a tattoo. Yeah, it becomes bigger and bigger and bigger. Okay, gravitation of an ideology. Okay. Okay, so that's what it is. I hope you like this. It's ugly, but yeah, look at tattoo, it's ugly, right? But our humanological analysis, I don't know about you, but I think it's something very beautiful. Okay, because we are using these planets and gravitation, the physics, astrology concept to explain metaphysical world, like tattooism. All right. It's ugly, but it's beautiful. Okay. I think that's why God created this evil ideology of tattooism, so that we humanologists, we eat it, we kill it, we eat it, we assimilate it. It becomes part of our body of humanology, body of knowledge, corpus of knowledge. Yeah, tattooism is evil, it's satanic. Okay, because there's no good in it. Okay, art. Why do you have to do it on a human body? Why don't you put on a painting and put it in the wall? Why don't you tattoo your wall, tattoo your painting canvas, or tattoo your guitar or your furniture or your eraser, whatever, your cell phone, your laptop, computer? Yeah, you can tattoo those things. Those are arts, but you cannot do that on a human being. Okay, because that's blasphemy, sacrilegious, blasphemous. Because we are made after God's image. Okay, so it's like just ugly. Okay, so yeah, if you have tattoos, save some money, get a better job, save some money, and get rid of it. Go to plastic surgeon and yeah, laser surgery, get rid of that. At least cover it up, hide it, don't show it to other people because it's ugly. Okay. All right. I mean, I'm not blaming you. I mean, you're just a victim of tattooism. You're chosen by God to be a victim of tattooism. Okay, it's not your fault. We all make mistakes. We have long-lasting mistakes. I mean, I was bicycling down, and I confess you, I was drunk. Okay. Thank goodness I didn't hurt anybody else. So yeah, I was drinking and bicycling. And I was doing like two-finger bicycling. Okay, because I know how to bicycle without any hands on the handle. Okay. And I hit a tree bump and tree root sticking on the bicycle track, so I fell and I broke my clavicle here. So that's the metal sticking the bones together. They did a fantastic job. Okay, this orthopedic surgeons, fantastic job. Nurses, yeah. But yeah, I feel it when I do push-up. Okay, so. It's all healed up, but still I kind of feel it sometimes. I'm kind of Frankenstein, so probably I will live with this until I die. Okay, long-lasting suffering from my past mistakes. We all make long-lasting mistakes like that. So yeah, it's not just you. Okay, so yeah, no worries. Everybody's like that. We make long-lasting mistakes. Okay. So yeah, just repent. Don't get any more tattoos. Okay, then you're fine. Okay, if you have tattoos, yeah, put some clothing on so that you don't show it to anybody else. until you get rid of it. After you save enough money for laser surgery, okay? Yeah, because tattoo is bad. Piercing, same thing. Take it off. You have some holes, well, go to plastic surgeon. They can get rid of those holes, okay? Yes, there's some good plastic surgery like that, okay? Yeah. They'll plug it off for you, okay? No worries. We have technology like that. So. They probably make some incision so that it kind of merge together. Whatever. Yeah, plastic surgeons can do that easily. Okay, that's what they do for a living, okay? So, gayism, tattooism, marijuanaism is all like that, okay? So, it gets bigger and bigger and bigger, but it's pro-gayism, pro-tattooism, pro-piercingism, pro-marijuanaism. They get bigger, okay? So, yeah, we are here to stop all that nonsense, okay? It's getting 3 hours, okay? So, we have to wrap it up, okay? So, we talked about this gravitation of this ideologies, okay? So, there's this gravitational force, okay? Temptation of the evil. So, yeah, please resist, okay? Be strong, be independent, okay? Then you can resist those evil ideologies, mainstream evil ideologies like tattooism, piercism, gayism, sugar fetishism, all that stuff, okay? All right, thank you. Happy New Year, okay? Bye.